Hello everyone. This video will show how to determine the area of a triangle given its vertices using the determinant of a matrix. Now let's go over this example. So we're given this triangle with these vertices A, B, and C. So I'm going to go ahead and sketch this triangle on this coordinate plane up here. Looking at this triangle right here, we can go ahead and say that the base of this triangle is 7. The height of this triangle, that means the line that goes from one of the vertices to the other side forming a right angle, is 6 units. So we can go ahead and use the formula for the area of a triangle, which is area is equal to 1/2 base times height. So I'm going to go ahead and show the work to determine the area for this. So using the formula for the area, we got 21 square units. Now let's use the determinant of a matrix to determine the area for this triangle. I'm going to go ahead and write the formula down here. This formula tells us that the area of a triangle using the determinant is equal to 1/2 of the absolute value of the determinant of the matrix, and the elements of the matrix are coming from the vertices of the triangle, and the third column will all be 1. So we can go ahead and say that this will be our x1, y1, x2, y2, x3, y3. So I'm going to go ahead and plug in these values into this equation up here. From here, we go ahead and find the determinant of the matrix that we have formed here. So the elements of the matrix that we got here are the coordinates of the vertices here, and then the third column will all be 1. So we go ahead and find the determinant of this matrix. So to find the determinant of this matrix right here, we're going to go ahead and copy these numbers that we got, which is the first row, -1, -2, and 1. And it will be in an absolute value. Now we remember that to find the determinant, we are going to alternate the sign plus, minus, plus, minus. If you notice, we wrote the first row down here, the elements of the first row. So we're going to go ahead and cover this row up here. And we are going to pair each of these with a 2x2 matrix. Let's start with -1. So we're going to cover the first column. And whatever is the leftover, that's the 2x2 matrix that we will multiply with the first number that we got here, -1. So this will be multiplied by 4, 1, -2, and 1. For the -2 right here, we will cover the middle column, whatever is the leftover. That's the 2x2 matrix that we're going to multiply to this. So that would be 1, 1, 6, and 1. And for the third number that we got here, we covered the third column, and the leftover will be the one that we multiplied to 1 here. So that's 1, 4, 6, and -2. And remember, we are going to determine the absolute value for whatever answer we got in the middle up here. So we go ahead and do the math here. So we have 1/2. Absolute value of positive times negative is -1. And then we are going to get the determinant of this 2x2 matrix. To do this, we are going to multiply their diagonals. So 4 times 1 is 4. Subtract it with the anti-diagonal, which is 1 times -2 is -2. And then we have a negative times a negative is a +2. And then we are going to get the determinant of this 2x2 matrix. 1 times 1 is 1, minus 1 times 6 is 6. And then we have a +1 times, we do the same thing. 1 times -2 is a -2, minus 6 times 4 is 24. So we go ahead and simplify this. We get 1/2 of the absolute value of, this turns into a plus, so that is -1 times 6 plus 2 times negative 5 plus 1 times negative 26. So I'm going to go ahead and simplify this value that we have up here. So the area of this triangle using the determinant of a matrix is 21 square units because the absolute value of 42 is positive 42. Half of positive 42 is 21. Please notice that this value that we have here matches up with the formula that we used at the beginning. Area is equal to 1/2 base times height. So that is how we determine the area of a triangle given the vertices of a triangle using the determinant of a matrix.